going on. I don't know its current status because obviously it's some of it is just happening, so they're not publishing. But it's a great opportunity to create a university town, Columbus, and then make it a smart city combined with university, different companies and the government and so on. So we'll see, and that's kind of one of the test beds that the government is pushing for. And hopefully it gives an idea what works and what doesn't work. My feeling is that it's unfair to expect that all these things will work 100%, then we won't learn anything. We'll just have a place that's really nice. It's also important to see what doesn't work, and I think this experiment will allow us to do that. On the other hand, there is a lot of similar projects going on all over the world, not just on the government side, but also with the companies. So I took this quote from Guardian. They talk about different initiatives in Asia, in Europe, and so on. So for example, Cisco is building a so-called smart city space in Adelaide. So that is one thing that caught my attention because it's very similar to what Sidewalk Labs is trying to do in Toronto, but it's before that. So if you look at the smart city idea, at its heart is what's called Internet of Things. What is Internet of Things? It's things that are not humans, that are talking to each other, exchanging information. Cars, your toaster, your refrigerator, your home, your heater, everything that in general you don't expect to talk to each other, talking to each other, expecting, exchanging information and trying to help you to improve the system. So these are some of the programs that are interesting. For example, London has been working on a smart parking project. There's a car sharing program again, allowing people to exchange information. In Paris, Copenhagen decided to build a sensor network to monitor bike traffic. Brooklyn and Camden, they invested on gunshot detection. Cameras that are connected to street lights. In San Diego, actually, was one of the proposals that review panel that reviewed their proposal. This is not the same thing, but they've been doing that. And New York City is one of the largest ones. I don't know if you've heard of it. I think Google had a deal with them to convert all the public phones into kind of internet hubs, Wi-Fi hubs. A lot of them, so you can connect to internet through Wi-Fi, and then you can do whatever you want, but they also know what you're doing. So they're just like watching you somehow. So that's one of the things that you want to think about when you think about smart cities. I mean, it's helping you collect data information, things talk to each other, but also there is this big brother aspect of this. I'm not alarmist about that, but that's something that's happening. So, let me see. One of the things that really get a lot of attention recently, what Sidewalk Labs they're doing in Toronto. So there's some quotes, obviously like anything else, it starts with a big hype because Google and Sidewalk Labs are coming to Toronto, building the city of the tomorrow. And if you look at the pictures, the area that they're going to work on is not very attractive. It's kind of one of these like a post-industrial type of sites. They're going to build a new city of the future. They have their own ideas. There's an article basically. There's a link with their vision, 150-page vision. But in a nutshell, what is their vision? They want to build Android operating system for the cities. They don't want to build any of them. Okay, so it will be just an operating system. So people will come and use that operating system to exchange information, to make decisions, to control things. So they'll build the apps. The government, other companies, they want to be the Android people of the smart cities. But they have to make this kind of attractive. So they came up with many ideas. I'm going to put one of this about solid waste system, smart system. So you live in an apartment building, you use the chute, it knows to separate recyclables from non-recyclables and then sends them directly to the factory and just does all of that automatically. They're not in this business. They don't know how to do this physically. So somebody has to come to do this, but they will provide the information technology, IT background for this. So that's their vision of smart city, and they'll be at basically the digital layer, and everything else will happen underneath. That's what their vision statement in a nutshell says. But there's also other things that's important. If I go back, so people were very excited. Google is coming, but obviously when you start working on real stuff, cities are complicated. So there are some cracks. Some people don't like what you're trying to do. And I think they're going to find out very soon that it's not as easy as building an Android phone with an app and then say like, you build your apps. You know? Those apps, they have great influence on people. For this conference, on elderly people, on aging people, on regular people, on disabled people, on poor people, and so on. So it's not going to be that easy. So they're going to find out that it's not that easy. Similar to what they're finding out with autonomous vehicles. It's a great idea, but when you start deploying them, it's not that easy. I've been deploying a lot of technology in my career. We spent once to just a simple form detection system. It took us 6 months to deploy. We're not building the system. The system is ready. It takes 6 months to find a location, to get all the permits and so on to deploy that. This was many years ago. It's easier now, but so they'll find out. So that's something that the lessons learned to keep in mind. IBM is one of the pioneers of the smart cities. It's very similar. They have different components like government, infrastructure, transportation, so on. And they want to do the same thing. They want to build an operating system. They will put all that together. Obviously, IBM is kind of a different company than Google. They're more of a consulting company. So they were thinking of building consulting work around this, and they found it very difficult to do that with civilian government, basically civilian projects, city projects, state projects. They're not as easy as working with private sector or defense. So I don't want to, I don't know exactly their business, how much money they're making, but I think there's a little bit of a cold feet from IBM's side in terms of the excitement and the hype. But it's a very similar model, and they had this kind of a dashboard idea that I actually saw once in one of their presentations to basically show you the performance of the city as a whole, so monitoring the whole city. And the key is to have sensors all over the place. Another idea is that not only working for the whole city, but also buildings, monitoring what happens in a building, and then add that all that information in their performance measurement dashboard. So, if we use all of that, kind of an overall conceptual idea comes out about the cities. So about sensors and sensing. And there are many ways of doing that. It's about then big data and big data analytics that comes, and then you use that data, basically artificial intelligence techniques, machine learning techniques, and so on. And then there's open loop decision making. What I mean is, you have all this information, you make a decision, but it might take you 6 months, 1 day, and so on to implement that. So and then you might not follow up with it, But there's also this idea of closed loop decision making. That means that you make a decision, you watch what happens, and then you keep changing your decisions to optimize your system. And then I think that the final idea is to combine all of that and build an autonomous city. No mayor, no government, it just runs itself. I put in red. I don't think it will happen, but that's like if you're a technologist, if you're Google, if you are Facebook, probably that's what you're dreaming in a little room with all these very smart people. Like the city runs itself, okay? In a closed loop decision making. Will it happen? I don't know. So there's some references. People are writing papers about this thing. So there's a different way of looking at this. So you can look at this as networks. So to just make it a little bit more realistic. So there's a network of supply, logistics, network of transportation, network of energy. and then how those networks are related. So it makes the problem more interesting from researchers' perspective, but that's the real problem. So if something happens to one part of your network, the whole city is affected, so you have to really model this as a network problem. Okay, so there's a couple of slides I'm going to go through. So because I'm transportation, so I just wanted to look at different data for transportation. So they're driven by the user needs. And now, because we have all these sensors and sensing technologies, actually you can get most of the information that we need for transportation from the apps, from the sensors on the roadway, from your car, from your travel agent, from the airline company, and so on. So you can build a system that can monitor your transportation activities from this kind of information. In the past, we didn't have any of that information. So that's really exciting for us. And actually, we are working with most of this data. So in the past, I mean, we have like this, maybe first 3-4 areas like Bluetooth, the tube counters and loop detectors, manual recording, maybe CCTV. But now if you look at the rest, there's a lot of new data that's coming in. So that's good news for us, for researchers, for transportation people, because really we can use this data to better understand what works, to better understand how people are moving, and then make decisions. Obviously, smartphone is one tool that really allows us to get most of this data, but all the apps that are running on the smartphone also are helping us. So Underline Knowledge has some work on using Twitter, for example. We do the same thing to detect incidents, to understand how people react to incidents and so on. So this is really exciting for transportation people, and that's part of the smart city. We are using it for transportation. People are using this for addressing crime, for addressing healthcare problems, and so on. All this data on this side, on the right side. That side is mainly transportation. Okay? So in response to this big explosion in data, the availability of data and its implications on transportation, we created this center, and this is the long name that Anil couldn't remember. It's Connected Cities for Smart Mobility Towards Accessible and Resilient Transportation. The only reason we had that, we wanted to have C2 Smart. So you come up with the, I'm kidding, but I mean, these are all things that we wanted to have, but also there's a nice acronym. So this was just 2 slides. I'm going to be very quick about this. This was a center that we got in 2017, part of this Department of Transportation competition. And its main goal is to deal with cities and transportation. The reason I have this slide is because I also want to show you that they're dealing with different sizes of cities. So it's not just New York City. Rutgers is in New Brunswick, so it's a mid-sized city in New Jersey. University of Wisconsin is in, University of Washington is in Seattle. It's a larger city, but it's not New York. University of Texas El Paso is a smaller city, border city, and City College is a different part of New York with different kind of challenges. So the idea is to develop transportation solutions and transportation research at different scales, and then see if they're applicable at those different scales. What works in New York might not work in Texas El Paso. We want to find out about that, and then vice versa. And one of our missions is, I think it's relevant for this conference, is that we want deployable, actionable things. It's not just writing papers, but we are trying to implement things in the field. So these are some of the projects. I'm not going to go over them, but again, some of the projects are very relevant to this conference. So there's one project we started, it's problems with IRB, so we don't know where it's going to go. The first one, the top one. So there's an idea by some of our colleagues in behavioral economics to follow 10,000 people for 20 years using technology, 24/7, to see exactly what you're doing. Okay? So they already have funding from Kavli Foundation to do this. So imagine that might have great information about aging population. Somebody who is 40, by the time they're done, will be 60. Somebody who's 60 will be 80. So they want to, I mean, this is much more ambitious than a regular transportation project. They would like to know what you eat, how much you exercise, how much you go to mall versus to the park, everything, okay? So you can understand IRB is really like Okay, wow. Let's be careful. Okay. So I don't know if this will happen the way they are planning, although they have the money. But we are funding a small part of this to use the data relevant to transportation. So even if it doesn't happen, I think it's a great idea, and we will do some version of that. Okay. So let me just talk about one more project. It's the last bullet, the first and the last. This is called quantified community. Very similar. So in Hudson Yards, they're building a new city, basically, on the train rail station. So one of our PIs, he has a special relationship with the builder. So he is installing all kinds of sensors in this new community, basically, to understand how they, so this is not on the individual base, more aggregate base, but how people are moving within that community. And this is going to be hundreds of thousands of people when it's done. And how they're getting rid of their trash, and what kind of transportation mode they're using. So we are building sensors to monitor this community, and actually he's using the same idea in different communities in Brooklyn and in Queens. So this will be something interesting in model deployment. Most of it is anonymized, so we don't know who that is, but we have a good information about the activity in that community. And since this is being built from scratch, so there's an opportunity to instrument many functions. Okay, so I'm going to talk about two quick things, and then I know how much almost done?
Almost done.
Okay, so very quickly. So I mean, this transportation safety. So I mean, for this conference, I looked at the impact of car accidents on elderly population, and if you see here, it's huge. People who are involved in accidents who are older, they have a much higher probability of getting injured or killed. So there is a lot of good things we can do. People who, like me, working on traffic safety to help these populations. So this is some of the information from the US. And every study after study shows that if there's an accident, if somebody who is older than 65 is involved, the likelihood of being severely injured or killed is much higher than the rest of the population. So one project that we are doing, part of our Smart City Center, is also funded by AIG, the insurance company, to use the traffic cameras all over the New York City to get the information about vehicle movements and basically predict accidents before they happen or predict the risk levels at these intersections using that regular camera image and using what's called surrogate safety measures. I don't have time to talk about them. So this is one, and this is not New York, this is Russia, I guess. So you can really, if you can record it and then convert your video into trajectories, you can actually predict this accident before it happens and then provide information through technology to avoid this accident. These are the type of cameras that we are working in New York City, and actually we're able to use image processing techniques to get the trajectories and then do prediction in real time. Okay. There are a lot of challenges with using existing cameras, as you see it here, because they're not designed for this purpose. So you need to improve your image processing techniques to get better trajectories. We can also detect pedestrians, and in this case, you can find out about conflicts between vehicles and trajectories using this kind of image processing technology. And then, this is some of the research results. I don't have time to go over them. We use the surrogate safety measures to basically, as a method to warn people. So the other one we are doing right now, there are 3 test beds that are going on in the US on connected vehicles. One of them is in New York. The idea is to instrument 10,000 vehicles and some pedestrians. And part of that is to develop an app for visually impaired population to be able to move in the city, especially intersections, in a more safer way. So we are actually, so there are examples of that. and there's some very sophisticated ones with wearables. So what we're doing is not that sophisticated. Basically, it's an app, and when you approach and you're visually impaired and you have that app, you approach an intersection, it will warn you about the signal timing. And it will be tested with 100 people, and then we will be conducting the test as NYU, and then see if it's really helping. Obviously, this has, again, direct implications on the aging population, because people lose their eyesight, and then they actually become less agile, and then they cannot walk as fast. So if you have an app like that, you can also help aging populations. So conclusion is actually everything is great. Great things are happening. A lot of new technologies. What I'm going to finish it with one slide. This is something that I was doing almost I don't know 20 some years ago in 1995. With Raytheon building a smart park, smart parking lot. And still we're talking about this kind of things. At that time we were saying like all the parking lots will be smart in like a few years. Raytheon, they make these cruise missiles that they can go and everything. So for me to go to their facility, we had to get like all these clearances and everything. And then the first project they proposed was $10 million in 1995. So we went down like a very small number. But we were thinking that all the parking lots would be smart, very short period of time, and still didn't happen. I mean, you see a lot of projects now, they talk about smart parking, it's going to happen. So that's a word of warning. All these things sound very attractive, and it's going to happen tomorrow, but my experience takes a long time. So that's my word of warning. Right? So.
Any questions that you want to?
Really fascinating stuff. When you're doing community data collection, and so like in Hudson Yard, you're putting in sensors, do you have to get community when you're putting in sensors new, and basically it's almost research, do you have to get community consent? How do you get past this concept?
So there are different kind of sensors. So if I'm watching your Wi-Fi, you need to opt in. So there's a lot of opt-in, But if I'm just aggregating your waste usage, for example, that's the building. So the building has to know that that's happening. So depending upon what you're doing, there's a lot of that you have to do. And obviously, Universal also is watching what kind of data you're collecting. So basically, IRB is for that. But we never collect personal information. Personally identifiable. We try to not to do that. So if that's the case, we use opt-in type of apps. So if you're not opted in, we're not going to collect your data.
But when it's a population, so it's in like Hudson Yard, you're saying it's what, a 10-block radius.
Yes.
So you're collecting all this data, but people don't know it.
So there are a lot of signs. There's a lot of emails that go to them, so they definitely know. If they're collecting their personal information, I mean, not so personal, but their movement, for example. But other information, if it's very aggregate, that they don't know what the building knows or the other entities they know. So there's no secrets. It's always.
Do we have any more questions? Two mics.
So when you have something like gunshot sensors associated with a street light, is there the possibility to have short-term loop photography that would be triggered for retention if the gunshot was heard, to actually have some response to crime rather than just aggregating general data of areas?
I don't think this app, this deployment has that, but definitely that's a possibility. And I mean, one of the ideas is that instead of adding a new camera for all kinds of different applications, can you use existing cameras like we did with the traffic cameras, for example? There are a lot of cameras in every neighborhood, for different reasons. So there's no reason not combine all of that with the gunshot as a warning and then take a picture. But I don't think this one has that capability. It can be done, definitely. You want to be careful how much data you collect. You know, I mean, we have. I didn't talk about in other apps. We're doing the infrared imaging of the city from high buildings, and the data that's coming in every day, I think it's like 1 terabyte. So that's. I mean, you're talking about huge amounts of data.
So, okay, so for the data that you have, what would be the most challenging technical problem that you have?
So I think so I coined this term. Probably other people came up with it, so I'm not the first one. There's this kind of big data. There's a black hole problem. The data is like water coming in, but if you want to get it out, it's a big issue. So you want to do everything in the cloud, for example. So actually moving data around is the biggest challenge. The other one is the quality of the data, because the data is very noisy. I mean, you're working with real world. So with this image processing, for example, I mean, you read all the papers, everybody who's doing work in the lab, everything works perfectly. When you start using the data from traffic cameras, nothing works, okay? Because of occlusion, because of...
I think you need a computer vision person.
We have excellent computer vision people, but they all work in their labs. They don't work in the real world. And then when they give them this, actually this project had a computer vision person, and they failed, I mean, miserably first, because the data, I mean, the image they see is very different than the controlled image that they collect. And every camera is different, and the angle is different, and New York is a very messy place. I mean, you have a truck like standing in front of the camera, all that stuff. So you need to really clean that noise. So that, I mean, I think that's the biggest challenge. I mean, we know how to do things, but deploying them and doing them in the real world is a different problem.
Thank you. Now we have to move to the next.
Yes.
Thank you. That's good.